The formidable powers of the sun have made it, for thousands of years, the object of terror, worship, and even intrigue. Although this source of seemingly inexhaustible energy has been the object of intense study since man's thought processes first evolved, it's only since the turn of the century that efforts have been initiated to tap this source. Our story today deals with a water body, a pond that will entrap solar energy, another step in man's struggle to harness non-conventional sources of energy for the future.
The need to harness non-conventional energy sources has become imperative in the face of fast depleting fossil fuels. Among the various methods applied to harness the sun's energy, the solar pond technology seems to be a promising alternative. The recently constructed solar pond at Kutch Dairy in Bhuj is the largest operating solar pond of its kind in the world. Developed by Gujarat Energy Development Agency in collaboration with TERI and Dairy Development Corporation, solar ponds have the unique ability to entrap and store the sun's heat energy for months together, even during adverse cloudy season, and this is a distinct advantage over other methods of solar collection. A technology demonstrated by Israeli scientists way back in 1958, this concept of solar pond is inspired by nature. In natural ponds, the sun's heat energy radiates to the bottom of the pond and heats up the water. The heated layer of water at the bottom, being lighter than the upper layers, rises to the surface of the pond, creating a convective motion and subsequently loses heat to the atmosphere. This convective cycle continues, and hence the temperature of the pond usually remains constant. It is generally observed that at sea, when the water at the seabed has higher salinity, the water temperature is warm. The salt gradient solar pond uses this phenomenon of entrapping heat energy. It consists of three zones: the lower convective layer with a specific gravity raised to 1.9 by concentrating common salt at the bottom, the middle layer with a gradient of salinity, and topped by the upper convective layer of almost fresh water. To suppress wave formation due to wind, wire nets are installed every 10 meters. As a result of this special construction, the heat from the sun is retained at the bottom of the pond. This is because the lower layer is denser than the upper layers, and the convective motion is thus restricted to the lower region. It takes about 30 days to raise the temperature of the lower layer to 70 degrees Celsius and even as high as 90 degrees Celsius. The hot brine pumped into the heat exchanger vaporizes the liquid of furon, and with the resulting pressure, a turbine is run. This kinetic energy can be used to produce electricity and for processing heat applications like desalination and refrigeration. The renewable nature of this energy makes solar pond a viable proposition for the future.